So this is the chicken ice melter in action. If we look over here, we're at 21.1 volts and 0.83 amps, 17.9 watts right now. And I got a 6 ohm resistor over here, 3 ohms, and they are quite hot. I'll show you the screen later. But, you know, this only has 15 components on it, so that's not too much. I'm running off a 50 watt solar panel, and that has a power point of about 20.5 volts, but it's winter, so it's a little colder. And so I just set this for 21, figuring anytime it's going to be used, it's going to be melting ice, so it's going to be cold out. I have one of these Peace Fair power meters, and these things do not like to start up on solar. I had this thing so it would come on automatically in the morning, and it was just partial characters on the whole screen. It took me, basically you have to power these things off for about 20 minutes before they'll actually reset, and then you can apply power and you get a display back. But I'm running off 70 feet of extension cord. This goes down to the basement. I have a electric cord coming from my shed outside, which has an AC outlet. So it's the panels to a little AC cord to the shed, and the shed inside, and that's about 20 feet. And this is a 50-foot extension cord. The other extension cord has a kind of a lot of resistance to it. People don't realize how much resistance there is in wire. I was looking for a cord to hook up the solar panel with, and I had a cord to a vacuum, and I was measuring ohmage on it just to make sure I had the right polarity for the hot, and I like to make the neutral minus. And I measured like 1.5 ohms, so I had 3 ohms when I shorted everything together, and this was only like a 12-foot extension cord. They must use like number 20 wire inside. It's really small. But so I'm losing some power, and I say this is only 50 watts, and I'm getting 27 watts from this right now. So there's the screen. This is the on time. This is the signal on the little gray capacitor. This is what my second op amp looks at to switch on and off. And you know, it's nice and clean. It humps up a little bit, but it's switching down here. So if we moved this trace up, you could see at which point it's switching, and that's a fairly low voltage that it's switching at. You know, our reference is like 2 volts, and so up here at the peak, you're seeing like the full 12 volts of the op amp. And so this is a really clean signal. Up at the top, we're only getting about 1 volt differential, and that figures out to be about 5%. And that's where you want things to be. Down low is the FET switching on. So we're actually measuring from the drain source to the drain the source we're measuring. And so this low portion is when this resistor is being heated, and these things are quite hot. And you know, I figure you only need about 20 watts to melt the ice. And really, in the winter, if you look right here, I'm only getting 0.85 amps. So 0.85 amps into 8 volts, you'd only be getting about 6 watts if you did a direct connect. And this is 6 ohms. You know, people would be saying you should have a 2 ohm resistor for this 50 watt panel. So I'm going to do something right here a little different. You can never find a lead when you want one. But let's just short out one of these resistors. And you can see that the wattage stays about the same. Now if we look on the waveform, you can see the duty cycle changes, but we're still getting the same power when we switch back and forth. And the current remains the same. So this works. This will match about anything. You want to have as high a resistance for a heating element as you can stand, but it'll work into lower. Remember, it's an RC time constant, and these are 3 1500 microfarads. And I chose 3 because I wanted to keep the current to like under an amp on each one. And it's a little less than that because you're providing power from the panel and from the capacitors, but every time you pulse, you're pulsing at maximum current. So this is a very high current path, and the current is always the same. But I hope that is interesting for you, and you should build some of these.